Guest of honor, Professor Ma Ngai is still fixing his PowerPoint. So, Undersecretary Victor Tai, 局長你好。Our honorable legislative members, Andrew, Benson, Elizabeth, S.H. 仲有幾邊個啊 ？There's still quite a lot 嚟嘅。冇啦。And also our previous CIC chairman, KK. And we have got a lot of developers here. Mike Wong from Sun Hong Kai, Wing Tai, Kenneth Ng, Swire. So a lot of distinguished guests sitting here. And also ex-Minister of Housing and Transport, Fan Ko. And also our ex-Minister of Innovation, Alpha Sid. Okay. I hope I now cover, I think, everyone. So, okay. My warm welcome to our Professor Ma Ngai 教授。So, distinguished guests, ladies and gentlemen, welcome once again to our CIC See What I See luncheon, 香港建造業嘅新視野。Here now comes the summertime. I do hope the future of our industry is as bright as the afternoon sun. But please be aware we are most vulnerable during this period of time. The heat, the rain, the typhoon, they will all put our beloved workers, our beloved project at stake. There's no way that human beings can fight against the weather. But there's always ways that we can protect ourselves from it. As a manager and directors of different projects, we need to have our hardware or some gear where we must show care to our workers. We can also make use of different gears and technology to help us achieve this. And here is some example that may inspire you. Okay.有蓋同埋有風扇咁啊，即刻可以減到30啦，減30分鐘。每3層咧，我哋就會有呢個咁嘅休息區啦，咁都會擺咗喺個露台附近咧，咁通風良好啦。你有埋呢個 screen， 話埋俾人聽，哇！一黃紅即刻可以即刻睇得到，即係最緊要都係 communicate 同埋咧係有演練嘅，因為有演練佢咁樣自己都知道有啲咩解決嘅方法。生命第一，對中暑說不。Yeah! So those actions are really the old actions as indicated by the CIC guideline last year. We've all been doing this, I think, real well last year already. With those sort of measures, you can reduce the 45 minutes to 50 minutes. This is not difficult to do. But the most important thing is to have practice and drills. Make sure our workers and our frontline would aware of the problem would arise and make practice on this. Recently, I have paid several visits to our partners in Greater Bay Area, and what impressed me the most is that they have now adopted digitization to a very far extent. And they have really demonstrated the ideals of smart safety site system. Everything, or almost everything, will be there on the panels. Are workers in the danger zone or fatal zones? What kind of work are they participating in? Are there any unsafe acts? They are all being demonstrated. And even workers' health condition, all this information leaps to our eyes. The reason behind all these successes, I would say, is commitment and passion of our leaders, and of course, artificial intelligence, which has leveraged the system by means of analyzing the data, monitoring site safety, and detecting abnormal behavior. There's much more AI can do in construction, ranging from cost prediction, design optimization, and project planning, etc. I will leave that to all the experts here. But what I want to say here is CIC is committed to training up our practitioners and equipping them with the up-to-date skills. This is the video shown in our recent CDE Award kick-off ceremony, demonstrating how AI has been used in the total life cycle, the total asset life cycle. Let us have a look at the video. In fact, we are seeing a lot of these projects around us, like the Henderson, like the ICC, like the Hao Ming Gai, like what Development Bureau has been doing, this DWSS. In fact, the IDWS has been implemented, 190 billion worth of work already. The platforms are there. Our masterclass series is receiving overwhelming support from the industry since it was launched last year. Today, we have invited 4 graduates from the AI Masterclass to join our luncheon and to share the experience on how AI has actually come into play in our daily world. Today, we are very honored to have Professor Ma Ngai, Director and Chair Professor of Hong Kong U Musketeers Foundation Institute of Data Science, to give us a speech on the past, present, future of AI and its implication in our construction sector. Professor Ma is a world-class scholar and industry sector transformers in the field of computing science and computing vision, has been engaged in the research of 3D computer vision, high-dimensional data and analysis, and machine learning for many years. In fact, he had put in a lot of his theory into practices around the world as well. As a professor at the Department of Electrical Engineering and Computer Sciences at UC Berkeley, Professor Ma had decided to return to China and come to Hong Kong to lead the newly established Institute of Data Science at Hong Kong U earlier this year. We are truly grateful, Professor Ma, of your decision, and we welcome you for your presence today. I'm sure this afternoon we have a fruitful event. Before I pass the stage to you, Professor, may I first invite our AI Masterclass graduate to come on the stage to give us their sharing Let's give a big round of applause to all of them.
Us. Ladies and gentlemen, let's welcome our moderator, Charles.
OK， 好，大家好啊！咁歡迎大家今日出席我哋呢個 CIC 嘅 luncheon 啊！咁頭先我哋 Chairman 講咗 AI 嚇，咁頭先嗰段音樂大家有冇聽過？可能未必有聽過。咁我話俾大家聽，其實頭先段音樂係 AI 做出嚟嘅。其實 AI 唔係淨係喺 music，AI 其實喺 construction 已經做緊好多嘢。所以 that's why 我哋今日好榮幸啊！我哋請到4位我哋 AI Masterclass 嘅學員咧，同大家有分享。不如大家一齊熱烈掌聲歡迎佢哋4位啊！分別就係來自 MTR 嘅 Henry， 跟住嘅 SY， 跟住咁不如咁啦，我哋事不宜遲啦。我哋首先咧邀請來自 MTR 嘅 Henry 同我哋第一個分享，好嘛？將時間交俾你 Henry。
好，大家好，咁就係 Henry， 咁就嚟自 MTR 嘅，咁就好多謝CIC 今日嘅邀請啦，咁就分享少少即係心得或者係即係睇法。咁今日我會講兩樣嘢嘅，第一就係喺 AI 嗰個 Master Course 究竟學到啲咩應用咧？第二就係分享下究竟AI 對construction industry 嚟緊一啲即係影響啦。咁 to start with 其實就見到個 digital transformations 喺呢個工程界或者建築業界咧，過往嘅10年其實嗰個 impact 好大，或者個 transformation 好大。咁有少少 data 嘅數據或者係即係貨物 McKinsey 啊嘛，其實見到過往嗰5年啦，喺工程同埋建造業嘅科技投資咧，其實係爆炸性增長嘅，比起即係其他行業其實都一個好大嘅增幅。咁個 implication 係咩咧？其實就係即係見到唔同業界同埋可能就 from investment 入邊都對呢個前景咧，其實有一個好正面嘅睇法咯。咁如果 put into context 香港嚟緊嘅嗰10年咧，其實見到其實會係一個好好嘅應用場景啦，做呢個 digital transformations。尤其是嚟緊可能每年都有3000億或者再多啲嘅工程量啦。咁所以香港會係一個好好嘅 testing ground 做呢個 digital transformations。咁喺呢個大環境底下，究竟即係我哋 MTR 做到啲乜嘢咧？其實我哋近排就推出咗一個 transformation journey 變革旅程，咁啊叫做 transforming the futures。喺裏邊底下其實digital 係一個 key enablers。咁我哋喺即係推進新項目啊，同埋新嘅project 嘅方面咧，就有3個 pillar 嘅。第一就係 digital engineering。咁我哋會喺嚟緊一啲項目咧，就大力推進 BIM 同埋 CD 嘅應用啦。咁就幫我哋做設計啦，同埋一個 collaborations。第二方面就係 digital project management。咁我哋會用科技啦，同埋數碼化咁樣幫我哋去管控我哋嗰個進度啊，同埋我哋嗰個支出，咁就提升我哋嗰個項目管理效率。最後一方面就係 digital on-site， 咁我哋就會用數碼化或者頭先一陣講嘅 AI， 幫我哋去提升嗰個工地安全啊，同埋質量管理咁樣。咁 specifically 嚟講，我哋即係喺嚟緊項目 AI 會用喺邊方面啦？咁其實我哋就會喺新嘅項目裏面就做一個叫做 Smart Site Management Platform， 或者業界叫 CIC 啦。咁啊包括啲咩咧 ？AI 應用，咁啊例如話我哋會用 AI 幫我哋睇住可能地盤嘅可能一啲工地工作人員啊，或者一啲儀器啊，佢嘅係咪喺一個安全嗰個工作環境底下做一個工程啦？咁另外一方面就係我哋會做用 AI 嚟做一個 quality management 同埋 progress checking 嘅。例如話我哋會喺地盤用嗰啲影啲相，咁用 AI 咧就 check against 嗰個 BIM model， 睇下會唔會有啲唔同即係分別，同埋我哋就係 check against 個 program 會唔會係跟翻個 on track 咁樣咯。咁最後一樣都重要嘅，咁就而家 potential 睇緊嘅就係究竟喺 ESG 方面會唔會有幫助咧？尤其是我哋 construction industry 喺 embodied carbon 方面，其實都 contribute 咗好大個 carbon footprint。咁如果我哋用到 AI 喺嗰啲平台上面做到呢個 carbon footprint 嘅 tracking， 咁我相信對即係2025年嗰個net carbon zero 嗰個 target 其實都會好大幫助。咁最後少少分享就係一個命題，就係究竟generative AI 或者 ChatGPT 對工程業界會唔會係下一個嘅 iPhone moment 咧？點解咁講咧？其實見到兩個現象嘅。第一就係其實工程界朋友即係或者同事咧，其實都好自然其實會用嗰個 ChatGPT 嘅。咁大家見到其實 digital transformation 最難係咩？就係改變人啊嘛 ，change behaviour 啊嘛。咁喺 ChatGPT 呢度其實見到好多人即係業界朋友其實 唔係 passively 去即係被逼去用，而係佢 proactively 去 change behaviour 去用呢件事。咁所以個 digital transformation 其實已經行咗一大步咯。咁另外一個方面就係 ChatGPT 嗰個對我諗業界個 impact。咁其實佢唔止 construction industry，其實喺其他 industry 都有一個好大嘅影響。咁所以如果嚟緊喺即係個 application 或者一啲 plug-in 或者係一啲即係 foundation model，如果有更加多推進係一個 construction 即係 applications 嘅話咧，我相信對業界嗰個管理提升啊，或者係嗰個技術嗰個uplift 其實會有好大幫助咯。所以作為即係其中一個持份者，我都好 looking forward 就係希望 AI 會幫到業界繼續呢個提升嗰個技術啦。咁最後就多謝翻 CIC 就arrange 個 AI CIC 嘅 course 嘅 master course，咁係喺裏邊亦都學到好多即係 AI 嘅新發展。咁就多謝各位。
OK， 好多謝晒 Henry 嘅分享啊！咁其實咧呢個 iPhone moment 已經出現咗㗎啦，在座咁多位，所以 that's why 我哋都要擁抱呢個 AI。好啦，接住落嚟咧，我哋有第二位咁來自 Atkins 嘅，咁就係 SY Liu 嚇。咁SY 要用英文同大家分享嘅。OK， 我將時間交俾 SY 嚇。
Thank you, Charles. Pleasure to be here. Thank you for the invitation, CIC. So I'm SY from Atkins, and I had the pleasure to also join the CIC masterclass. And I will share some discussion points, and also after share something Atkins developed for a client on a project and for a highways project. So on our masterclass, we looked at how we can reduce Hong Kong HVAC demand. 40%, okay, is the electrical demand from HVAC in the commercial and public sector. So we can monitor contributing factors such as weather, demographics, and activity levels. Then with AI, we can read the live data or to automate adjustments to the building services. Okay. Automatically turn off, power down, align output with real demand. And then we can take this further and predict building performance, plan operational costs more accurately. Okay. And if we align our industry to improve data sets, we can apply deep learning for data repositories such as the CSDI. So something that Atkins have developed for a client on a highways project, we use AI to reduce human error and process large amounts of data. So in this case, we identify defects in schedule maintenance. How do we do this? So we take the photos along the highway and then align the photos with the model. Okay. And we can do this because the photos have all the metadata inside. Okay. And this is what we get back after processing. Okay. By training the model and machine learning, we can identify defects with an accuracy of 90% or an error rate of 10%. And so with this information, we can feed this into forms and create work orders, schedule maintenance, and similar to what we are doing in Hong Kong with the WSS solutions. Okay. So this solution was applied to highways, but we are also applying this to rail infrastructure operations. So we are very excited to see where AI is going to take us and how we're going to engineer a better future for our planet and its people. Thank you very much.
Okay, thank you, SY。大家睇到呢個係即係 AI 嘅其中一個 application 嗬。咁嚟緊啦，我知道咧有來自發展局嘅 Joanne， 咁有好多都係來自政府嗰邊嘅 application 嘅。我將時間交俾 Joanne 啦。
主席、各位嘉賓、各位朋友，我係Joanne Q， 而家喺發展局工作嘅。咁 YC 咧就叫我同大家介紹下 Common Spatial Data Infrastructure and the Smart Construction。咁其實政府咧就已經幫大家起好咗一個平台，係空間數據共享平台。咁喺2022年5月，我哋已經將呢一個空間數據共享平台開放咗俾政府部門。去到22年尾咧，我哋已經將呢個平台開放俾公眾，喺入邊可以有超過500 set 嘅 data set。咁我哋預計去到25年尾咧，應該我哋有超過900 set 嘅 spatial data 喺上邊。講到 data 咧，其實而家有超過50幾個部門咧提供咗數據分享。咁包括有 3D visualization map， 你見到好精準、好靚嘅一啲 3D map data。咁亦都有 3D 嘅 indoor map。去到今年年尾咧，我哋有超過1250個 building， 佢個 indoor map 可以喺平台數據發放。咁而講到 3D pedestrian network 咧，我哋而家加緊做緊， 好快亦都會喺呢個 CSDI 嘅 portal 見得到。咁其實我見到咧 CIC 行得好快，行得好前，一早已經揾咗 consultant 做咗 study。喺顧問公司嘅 report 咧，我哋見到例如 CEDD 嘅 natural terrain landslide inventory 啦、LiDAR data 啦，或者係啲 slope 嘅 registration information， 對於做 geotechnical 嘅 study 咧好有幫助嘅。喺唔同嘅 event 啦，包括頭先我見到 Chairman 嘅 opening speech 啦，或者係 MIC 嘅 introduction 啦，都其實見得到有好多唔同嘅 3D models 出現嘅。咁講到去 AI 啦，我啱啱咧就喺 CIC 上完嘅 AI Master Class。咁其實我覺得呢個課程咧係好精彩，好值得推介。咁當我哋做 group project 嘅時候咧，我哋都用咗好大量嘅，包括係 3D environment 嘅 data 啦、underground utility 嘅 3D 啦，去幫助我哋做一啲 AI in design， 特別係 design optimization， 即係我哋將 AI 嘅 concept 擺咗落去我哋 construction 嘅 project 嗰度去應用。咁跟住講到係 BIM 啦，咁我相信在座各位都係業界嘅好熟悉 BIM。應該對 BIM 嘅了解多過我，包括有 design 啦、construction 啦，去到 as-built 咧，都已經全面用咗 BIM 㗎啦。而政府做緊個 Government BIM Data Repository， 做完之後嘅 data 咧，亦都可以喺呢一個 CSDI 嘅 portal 嗰度發放。咁其實今朝早啦，我都喺政府總部開緊會嘅。咁Chairman 講咗一句説話。佢話1+1不等於2，其實都用喺我哋呢個 situation。頭先我哋講到 geospatial industry， 其實係唔單止可以幫到做 BIM、digital twin 同埋 smart city。相信我哋喺 digital construction， 在座大家一齊去用，可以幫我哋 constructing 一個 smart future。多謝大家。
好，多謝晒 Joanne 啊 ，OK。咁大家記得呢個 CSDI 咯嚇 ，Common Spatial Data Infrastructure 嚇。好啦，咁啊 last but not the least， 我哋邀請咧就係協興嘅 Kelvin， 好，將時間交俾你。
係，大家好，我係嚟自協興嘅 Kelvin 梁。咁今日同大家分享咧，就首先就 CIC 呢個 course， 你見到我哋好包括業主啦，包括我哋政府啦嘅同埋顧問啦，同埋我哋 contractor 啦。咁其實係成個生態鏈喺度出現咗嘅。咁喺個 AI， 我哋學到啲咩咧？我哋會發現到咧，其實 AI 可以幫到我哋慳到啲 cost 啊，又更加有效。其實大家都知嘅，咁我唔喺度詳細講。我哋講講咧，喺我哋協興咧有啲咩 idea 係想去推廣或者叫做去實行咧。咁第一個 idea 咧就係我哋係透過呢個 teamwork design。teamwork design 我哋基本上每個地盤都需要嘅，譬如有啲每個地盤都有啲 transfer pay 啊去做。咁我哋係希望可以咧利用呢個 design for construction 同埋 design for safety 喺度去處理。咁點樣處理咧？就利用埋頭先阿 Joanne 所講啦，有個 BIM 啦 ，BIM model， 然後用 AI 去 fit 入去 crossover 去運行。呢個係一個比較新嘅概念，所以呢個比較困難，但係我哋都係做緊。好啦，第二個 idea 我哋應該相對比較成熟嘅就係 4S。4S 裏邊其中一個 working height 即係安全個管理咧，去到一個 working height 方面咧，其實現在我哋有係譬如安全帽嘅佩戴啊咁樣樣。咁我哋發現一樣嘢，如果去到 working height，當個工人戴咗個安全帶，發覺原來 AI 認唔到嘅喎。咁點解會有咁嘅情況發生嘅咧？就正就係我哋 AI 嘅 language 同埋我哋嘅construction language 嘅問題啦。即係我哋唔該轉隻 slide 係啦。咁我哋發現有佢嘅分嘢。點解會有咁分嘢咧？AI 話喂條繩白色認唔到，咁啊點處理咧？咁我哋安全繩喎，咁我哋自己同事咪俾咗你咯，咁咪搞唔掂。咁原來我哋市面上有啲黃黑嘅安全繩可以用，咁 AI 咪可以認到咯，咁可以減少嗰個嘅電腦 learning AI 嗰個時間。 咁除此之外，喂，有啲位置佢啲 cam 認唔到，即係遮住咗啦，咁點處理啊？喂，我哋又諗下，為一啲RFID 啊，利用一啲 IoT 嘅技術，可以用另一種方法去認一認嗰個AI 去知道已經個工人已經扣安全帶。咁講到尾，其實係我發現咧，好似10幾年前 BIM 啱啱推行嘅時間一樣。咁當時個業界未認識個 BIM。咁透過 CIC 好多嘅 training， 好多俾我哋業界好多訓練，就令到我哋就好開始了解 BIM 應用。到今天冇邊個唔識用 BIM。咁我見到 AI 個趨勢都係一樣，都係需要 CIC 幫手繼續開啲 course 俾我哋業界同事去多啲去學習。咁我相信未來10年之內咧，應該都可以走一個 AI 嘅發展嚇。唔該。
好多謝晒 Kelvin 啊 ，OK， 好。咁啊，頭先大家聽到4位學員啦，咁其實咧都講咗一個好重要嘅地方，就係啲人仲話 Why AI， 其實就唔係啦 ，Why not AI？ 其實我哋本身好似今日我嘅題目 Constructing our smart future， 我哋點樣去做到呢？擁抱 AI， 我哋要一齊努力去建造呢一個智能嘅未來。好啦，咁啊，希望大家再一次熱烈掌聲，多謝我哋今日4位我哋嘅分享嘉賓 ，OK。咁我將時間咧交俾 MC，Thank you。
Thank you. Thank you so much, Charles, Henry, SY, Joanne, and Calvin for the
All right. Thank you, everyone. It's actually absolutely great pleasure to honor to be invited to the Construction Council luncheon and to give a talk about it. As Thomas has introduced, I just joined Hong Kong U about in January. It's about less than half a year being here. I'm head of the new Data Science Institute, which you know, and also I will also 2 days from now I'll also be the head of the CS department of Hong Kong U. So basically, with trying to embark on the bigger mission of really build a strong, school of computing and AI and also data science. So today I just try to give you, I think right now, everybody's interested in AI, talk about it, but I can just assure you there's tremendous of hype, misunderstanding what existing AI is, to the point of creating a lot of hysteria, right? I mean, concerns. And the people have, the US Congress have, hearings about it. Should we be concerned? Should we be worried, right? Going to replace jobs. And there's a lot of has a complete misunderstanding of what AI, including the top experts in the world, because they don't know what they have done. They don't know what it is, right? So this is a lot of, hopefully today's talk give a little bit, clarify a lot of misunderstanding or what it really is, right? And this is what our job is, right? We do research in AI. We want to make sure we have a very objective view of it. Hopefully today's talk will convey a little bit of that to you, right? So we all know, right? In order to know, everybody is curious what's happening right now, or even more so is for the future, what AI is going to be, right? 5, 10 years from now, what it be? But we all know, right? Which is with a little bit of wisdom, we know, in order to see the future, you need to know your past, okay? Or the current. We'll be able to make more accurate projections. This is what the really thing is. Of course, one thing to get started, right? I mean, what is AI? What is intelligence, right? In fact, everybody, the reason why it's so so intriguing to people is that everybody think we're intelligent. Everybody think we know intelligence, right? We know ourselves, right? So, and yes, to some extent that's true, and it's not that mystery. And what we are trying to do with AI is not that mysterious. If you have this kind of way to really think yourself. And in fact, intelligence is a capability, right? Everybody equipped with it. We learn things, we become better, right? We know the world, we predict things, right? This is our capability, that's what intelligence does. In some sense, once you think about it, intelligence, our capability of intelligence is very the same as what we do with science. Science is make model of the world, make predictions, right? And in fact, what Einstein has already said, this is almost everything we do with intelligence. It's a principle. We try to make sense of the world, try to make anything predictable, memorize it, build a memory, and simplify it, and predict the future. That's essentially make everything as simple as possible, but not any simpler. This sentence actually carries tremendous information, right? And we want to see it a little bit later once we do. So to see the future, see the history, right? This is kind of the 80 years about the start of intelligence or neural networks. People are curious about how our brain function, try to model neural networks, right? 80 years ago, 1940s, McClure and the Pitts come up with first mathematical model to try to emulate what the neurons does, right? And of course, there's a history of it. And interestingly, almost every 30 years, right, there's a winter for understanding AI or neural networks, right? Both are because there's low lack of theory, okay? 1970s, people actually, now we think neural networks can do everything. No, it cannot. Okay, that's the biggest misunderstanding. In fact, in the 1970s, the two mathematicians showed that neural networks cannot even do very simple things, very simple logic things, XOR and so forth. So immediately push the study of neural network to a winter. Well, you cannot even do the simple things. How good it can be, right? That's still the case. Many people are made it to the contrary. What you believe how powerful neural networks are doing. In fact, it's very, very limited. And of course, 2000, right? People come up with other ways. There's still people insist, including people won the Turing Award, like Hinton or LaCoon, 1980s. They still insisted to the AI, right? And about 2000, actually they applied the neural networks to digital classification, recognition problems. They still believe it's useful, if not useful everything, at least useful for something, right? But around 2000, some mathematicians also discovered, even for recognition classification problem, there's a very mathematical, statistical principle way to do it, and also very efficient way of doing it. So that actually pushed neural network to the back doors, right? And in fact, for 20, 30 years, if you have any paper with the name neural network on it, you cannot publish it, okay? So it just tells us a little bit about our human nature, right? So that, of course, everybody knows what happens, right? Around 2000, just about 10 years ago, right? We call this magic decade for AI since 2012. I mean, we start to realize with the power of computing, with a lot of data, we actually can train the neural networks. At least they excel in certain large-scale image recognition problems, right? We can recognize thousands of classes, seems to beat all the other methods, right? That started to get people really interested in this topic. Of course, everybody know what happened, right? Then it gets applied to AlphaGo, gets applied to voice recognition, image recognition, autonomous driving, and so on and so forth, right? We call it a magical 10 years. Although we don't know what we did, okay? Everyone in the world don't know what it is, no matter what they think, okay? There's a lot of empirical approach, a lot of iteration between data and computing and so on and so forth. So of course everybody says that, it's artificial intelligence. Does anyone even know the history? Bother to check it out, right? It's artificial intelligence. The name comes from 1956, right? The summer program. And John McCarthy coined the word artificial intelligence. But turns out, right, this is the biggest misunderstanding, right? That artificial intelligence is not this artificial intelligence, okay? What they're talking about artificial intelligence, they're trying to separate the function of human, high-level functions of human, from the animals, low-level functions, okay? What is logic, causal relationships, and high-level problem-solving skills, right? Not the kind of AI we see in the past 10 years, right? The past 10 years, actually, we're learning, try to model structures of visual data, speech, language as signals, right? We're actually learning a model for the perception of the world. Try to make sense of the data, right? It's try to perceive, and basically, we try to understand the memory, what the words to memorize, how we use the memory for prediction and so on and so forth, right? Has little to do with the high-level intelligence, right? So in fact, we're even associating the name to the wrong thing, okay? That's how absurd things are. Once you look at things from the historical perspective, then the question is, what is the real history? Actually, it's the 1940s. That's a real magical decade. In fact, even more magic than what happened in the past 10 years. Because that's all the study of intelligence really started, right? 43, the neural network is modeled, and then Shannon created the information theory, 48, and the Nobel winner, which is the genius, this is the real hero behind intelligence, right? He actually wrote the feedback control cybernetics. And of course, von Neumann's game theory, right? Because those people, then we have the Turing test, right? For those people, those are really built the foundation of the intelligence we practiced in the last 10 years. Have everything to do it, if once you realize it, right? In fact, Nobel winner actually, for example, he has his book, this is 1948. For those people, they are just going after the true mechanism behind intelligence. Because for those people, they never separate the intelligence for machines and for animals. The title for cybernetics, the subtitle is Control and Communication in the Animal and the Machine. That's the true spirit of Turing test. If you discover the same mathematical mechanism or computational mechanism, you implement it either in the silicon-based or carbon-based, you cannot separate them. That's the true spirit of Turing test. It's not to ask some stupid questions, I cannot tell the difference, okay? So this is actually, those people are, in fact, those people actually discovered precisely, those are the key characteristics or mechanism behind intelligence. In fact, the last 10 years, all the practice, although implicitly, they actually take advantage of all this. So just now, with that history, let's recap what happened in the last 10 years. And maybe make more sense to all of you guys, right? So, for example, we have those images. We want to recognize them, right? Outside, those are all the world, right? We see images from our retinas. And then we try to recognize their apple, bird, cats, right? This is the first task neural networks see a little bit of success, right? 2012. Try to do ImageNet, categorize, classify thousands of classes. This is exactly going from the outside world into our brain, try to organize information, right? This is called recognition, right? Classification, and then we can do speech recognition. You can hear me, and also do object recognition, and then we see the first phase, right? Everybody building data sets, feeding this, classify, label them, and classify them, right? Then they apply to speech recognition, autonomous driving, and so on and so forth, right? See tremendous empirical success. But after a while, just human nature, we had enough of that. We start to think about something else to do, right? So this is going from outside world into our brain, right? To recognize things. Of course, what about the reverse, right? If I think about apple, can I draw apple? Our brain can do both, right? We can recognize things. We'll also be able to generate, project, and we'll be able to, that's exactly, we want to use this ability to do what? To do projection, right? So we visualize things. The visualization is necessary for us to predict what's going to happen in the world, right? So for example, this pointer, everybody knows what will happen if I drop it. I release my hand, everybody in the room is Newton. You know better gravity than you know yourself, okay? Since you're kids, you already know gravity. You have a model to it. The only difference between you and Newton is that Newton wrote it down as differential equations. You just have a different representation of the physical world, but they're doing exactly the same thing. Science and intelligence are doing exactly the same thing. We're modeling the world. Hence, we'll be able to recognize, we'll be able to project it, right? Help you to prediction. Of course, this is useful, right? So if I think about something, I can generate something, right? This capture people's attention. Everybody talk about generative AI. This is it. Just from something, you imagine something, and sample something, you can generate something, real-world data, right? Generate images, synthesize speech, and it's just very simple, just to regenerate. Now, this is the Midjourney and the Stable Diffusion, right? Create all kinds of hypes about how wonderful generative hypes is it. But can everybody realize, right? All this fancy, talking about all the method, but turns out the method behind the success of this generative model is actually 250 years old. It's called the Laplace method. Physicists rediscovered them 100 years ago. Okay, then we just rediscover another, right? In fact, this thing gets rediscovered many, many times, right? Basically, the right method to do this has been known for a long, long time. There's no intelligence, there's no rediscovery. It's just the implementation. You say, well, why so magical? Because now we have billions of images and thousands of GPUs. They just unleash the power of those mathematical methods, right? In the past, we just witnessed that in the past few years. So just to put things, and of course, everybody talk about the ChatGPT. It's exactly the same darn thing, right? So just generating image, and also generating sequence of sentences, natural language. They're just signals, right? We learn the distribution, we have to be able to generate them, right? So this is actually, large model is actually very simple. The training is extremely simple. Using the pretext to predict what's next, right? It's just like when we were kids, right? We're forced to memorize something. Right, your teacher will beat you if you don't remember the next word, right? That's it. We just coach the computer to do that. And this is just to help you to pre-train, right, to memorize, right? But only have the hard memory doesn't mean that you understand things, right? So that's why the next step is that you have to coach your system. In fact, this actually tells you how dumb the system right now is, right? They just coach to force you to memorize those things. They don't have to understand anything, right? So it's our human have to correct them afterwards, right? Then you just, this is exactly like your teacher, right? Ask you to complete a sentence or compose something and tell you the meaning is wrong, right? We get through that same process. We're coaching the machines like a baby, basically, right? The machine itself doesn't have any self-learning ability. It's all human doing. That's the artificial part of intelligence, right? So of course, you can see that with a lot of GPUs, the power of machine data, and you actually be able to do pretty well, right? GPT-3 talk about some emergence of sort of generative, sort of the general AI, right? Start to say elements of it, but it's still very hard from the, from our, if you understand the mechanism, how they learn, it's actually, there's very little mystery what they do, right? So don't try to make too much out of it. Right? At least from how they deal with data, process data, and the way human actually has to control everything. The machine, the system, literally has no intelligence. So there's two types of intelligence. One is just appear to be intelligent. So for example, we confuse people who has a photometric memory as being smart. We all know that's not true, right? And another thing is that, remember the history, 1940s. They don't want something behaves smart or intelligent. They want the machine have equipped with the same learning intelligent mechanism or become smarter and smarter, right? See, nobody go call a baby has no intelligence. Baby, once they're born, they're already equipped with the mechanism to learn, to get better. That's intelligence, okay? Not ChatGPT. So, of course, there's a lot of things, right? These days, everybody's trying to follow the ChatGPT, OpenAI. We see all kinds of hundreds, thousands of, right? People try to emulate in this. This is just the thing, right? So, well, what's next? For the interest of time, I'll just go very quickly. So, what's next? Once we understand the history, once we understand what we have done, right? It doesn't take a genius or Einstein to know what to do, right? See, first phase, outside to inside. Second phase, inside to outside. Our brain can do both. Our brain is a closed loop, right? That's a true memory. We can both recognize things, we also can project things, generate things, right? None of the existing system has even this kind of capability. We are way, way, way away from the truly intelligent systems, okay? We're just down half of the way, right? We pay a heavy price for that, actually, right? So, and also, of course, from our theoretical point of view, we want to understand why there's so much, even hinting, everybody say, oh, we're afraid that AI is here, it's going to destroy the world. No, absolutely not, okay? I think that's more self-promotion than truly, OpenAI want to regulate. They don't want to regulate themselves, they want to regulate other people, right? They're actually both self-promotion, self-protection. In fact, once we can understand deep network as a white box, what truly it's trying to do, and also architecture, what it's doing, then all this hype, all this, the hysteria will disappear. Just like any science, other science, right? Right. For example, before people understand astronomy, we think the sky is ruled by gods, right? Everybody has to sacrifice, right? I mean, we think it's very mysterious. We're in that phase, guys. We're very, very limited civilization. So this is another thing is that, yes, these days we can create big models, right? One analogy is that, Wright brothers shows us how to fly, right? One way to fly. Have some fixed wings, go fast enough, you fly, right? Yes, take about 100 years, we can build Boeing 747, Airbus 380. They are engineering models. They're very useful. You can make money out of it. But that does not say anything, this is the best way to fly, right? Nowhere competing in terms of efficiency, accuracy, agility with birds, insects. We're way away from that, right? So this is the truth about true intelligence. Nature's intelligence is very, very different, right? Different mechanism, much, much more efficient. Right now we have to burn gazillions of GPUs to get the level of ability, right? So the question is, can we actually truly be able to making everything white box, truly close the loop, be able to recognize and generate, and also to do things fully autonomously. The artificial intelligence, the word artificial really means human assisted, okay, these days. Right? We do everything. The machine has no intelligence, right? From the data preparation, choice of model, training the model, correct the error. Every single step, human is transplanting our knowledge into the system. Right? The system has zero intelligence in terms of mechanism, right? So can we actually do this? I'll go through very quickly. Yes, indeed. Once you realize what really intelligent learning is really trying to do, what our memory is trying to do, right? We make sense of all those high-dimensional data. We try to build a model of the world, right? The visual, speech, hearing, touch, all our 5 senses, right? We try to make a very internal structured model of the world. So that we can recognize from outside to inside, we can recognize from inside outside, we can project. That's it. Very, very simple, right? We want to simplify this world and learn what's necessary for our survival. Memorize everything's useful for our survival. Science is doing the same thing, okay? So how do you measure? Of course, try to make this purely scientific. Right now, instead of just, let's just label something, use a black box to fit data, then it turns out, once you realize that you actually can measure how good your model is, right? Those are the information theory give you this kind of quantity. How do you measure internally which model is better of the world, which contains more information than others? Right? How do we organize the information in our brain? This is the 1940s. Remember, Shannon's information theory precisely tells us how do we encode information in a very organized, structured way, right? Once you realize that, you just optimize those information. We call it information gain, or compress the data to reduce the coding rate, right? This is an objective measure. Then what you can find out is that once you do the optimization, then the network architecture becomes transparent. The neural network is just nature's way to optimize those things. The architecture just come out as a white box, right? See, nature doesn't have PyTorch. Nature doesn't have MATLAB, right? So in order for nature to optimize something, it's precisely realized with neural networks, right? So this is actually another thing. Remember, 1943, people come up with the neural network architecture sort of as a heuristics inspired by nature. They don't know what it does. They don't know why, right? A lot of the practice in the past 10 years, people try and error. They try different architecture, or this one works better than other ones, right? Even they trained the models gets randomly initialized, right? So, yeah, the model gets randomly initialized, gets trained as a black box. Even after you trained, it's still a black box, That's why people are so mysterious about it, right? Believe there's something magical power behind it. That's something we don't understand. That's usually the case. But turns out if you really, there's a way to really just to think about it from information point of view, that then the rest of the network is just to optimize it. That's the optimization. You can explain everything from the objective, from the architecture, from eventually what it has learned internally. Right. So there's actually mathematical formula. I'll skip for the interest of time. The one thing to do this exactly, so you can see that this kind of, we have outside the world senses, right? We really try to transcribe into our brain. The world transcribe is actually as a closed loop. From outside go inside, it's really our recognition. We recognize it's an apple. From inside outside, we try to say, this is what I think apple really looks like. Is my memory serving me right? Right? It's doing the projection. We try to constantly match our memory with the outside world. If there's any error, we correct it. Right? This is hence the feedback control system. Right? So again, people know that in 1940s. Information theory, feedback control, all gets invented in the 1940s. We just forgot about them, right? We're reinventing them in the past 10 years in a very, very clumsy way, very, very costly way. Okay, that's the situation. I'll skip this. This actually works very well if you actually can see that once you realize this is the system, a closed loop system, right? So everything, all the caveats people encountered when we were trying deep networks, right? Neural collapse, they're not very stable, and also there's a catastrophic forgetting. If you retrain neural network, the network forgets everything, right? It never actually happened with nature. You don't forget things just by learning a new word, right? So that's what happens if you have an open loop system. Right? That's why they train open GPT, right? 1.0, 2.0, 3.0. They have to retrain everything from scratch. We never reload ourselves, right? We never wipe our memory out and load another version. We don't do that. We learn everything. We never forget catastrophically, right? This is a new mechanism. Turns out that once you do closed loop learning, everything's stable. You don't lose anything, right? Right? You can. Also, that you don't have memory loss. I'll just skip all this. You actually learn more. Your memory will be organized, structured, rather than the hidden features. You don't know what it is, right? Another amazing thing is that this seems to be exactly what the nature is doing. This is an experiment on on monkey's brain. Monkeys memorize different categories of objects, right? This is actually, they precisely memorize, the memory of monkeys are very structured, right? Different categories are organized. Just like what learned here using the closed loop system, right? And so you can actually think about this, right? It's very ironic, right? Very, very ironic, guys. We celebrate the success of AI, right? Recognition, generation, right? We believe it's something alive, something magical, something powerful, right? Even better than human. But there's another big lesson. Everything in the world that is intelligent, that is even alive, is closed loop system. And all the system we practice so far are open loop. We pay a huge prices. We train end to end. We're pretty silly, right, sometimes. So nature has figured out much, much better way to learn, right? They're closed loop, self-consistent, and that utilize both forward, backwards, and it's highly, highly efficient and stable, right? This is what we believe, right? Nature actually learned. In fact, not just our brain is closed loop. Even DNA to proteins, it's called a transcription. The word transcription is precisely a closed loop. That's how we pass on information that is essential to our survival to the next generation. We use a closed loop system, right? Not open loop, right? Not thousands of GPUs, right? So in a sense, this is just to help people put some perspective, right? People become very, obnoxious about AI. Oh, we're system with a little bit, right? Suddenly everybody says, oh, deep network is all you need. We solve all the problems in the world. Really? We're that obnoxious? Or some people do reinforced learning, say, oh, reward is all we need, right? You see papers like that. Or certainly now transformer is very popular. People say, oh, attention is all we need, right? Hopefully, this lecture puts you in perspective how narrow-minded we are, or we have become, right? We're just driven by the hypes, right? We're far from there, right? So yet, 80 years ago, those few heroes already know way more than what we have know today. We're being practiced today about the true mechanism, information theory, the feedback control, and also the game theoretical approach to look at. That's the true spirit of Turing test. If we discover the same mechanism that behind autonomous intelligence, right, then you cannot separate machines from animals or human. Right? Doesn't matter if it's carbon-based or silicon-based. It's the same mechanism. That's when you should worry about machines, because that's when they become alive, right? Become autonomous. Just put this in perspective, right? In the past 10 years, we just practiced this as an open loop. Turns out really there should be closed loop. In fact, our brain is not just one loop. Our brain consists of hundreds of thousands of loops. Actually, if you look at our cortex, right? It's 200, a quarter millions of columns. Each one has the same structure, closed loop structure. So that's what the nature does, right? Something worked. What do they do? Copy. Right? Once they discover something works, they just copy. More cells, everything gets a reproduction. That's what they do. So basically, our brain is that we copy that for visual, we copy that for senses, for different senses, for touch. They're exactly the same mechanism. They don't need to discover new one for touch, one for speech, one for our smell. No, it's the same process. Model the world, making everything simple, extract the essential information, right? So last few years, I wanted to, even the OpenAI people these days is talking about really what really behind made their work, large model work, is actually compression. It's try to seek a compact representation and make them consistent. Those are all the most recent work. Just last couple of months, they are coming up with different ways to make things, right? They try to make things the closed loop. Now, so this is kind of giving a little overview of what the history and the past 10 years, and also maybe an outlook a little bit. How much there is for us AI or intelligent system to be done in the future, right? We're so limited right now, to the point where even celebrating mediocrity, honestly, if you think about it, right, compared to what we already know 80 years ago. So we're rediscovering things, right? So now the last few slides, very quickly, I just wanted to make some connection from very, very personal, right? I don't want to even pretend to be an expert in construction, but I do have a joint project with, started from a few years ago, with Professor Zhexiang Li of the University of Science and Technology. We have an Indo-Hong Kong project. Berkeley is a partner, so we're a partner with Zhexiang. So this is sort of a few slides I borrowed from him, right? The reason really, I think construction industry really sort of behind in terms of technology automation, right? Also because of our labor team is shrinking, especially this is the numbers from mainland China, right? It's very serious. Every year, there's a huge reduction of the workforce and the price is going up, right? So really the automation becomes very, very important. Right? Also, this is a sort of a technology history, right? Honestly, the reason I come to Hong Kong, I think Hong Kong has a huge room for high-tech industry, right? Hong Kong almost missed almost every single opportunity in the past 20, 30 years of high-tech revolution. Okay, starting from chips, internet, social networks, right? Artificial intelligence. We don't. Right? It's very serious for the leadership of the Hong Kong to think about it, right? Can we afford to lose another one, right? And so we talk about AI. Do you even know the entire Hong Kong, universities and the government, we don't even have a high-performance cluster. Yet, my student as an intern working at Microsoft, they have access to 500 GPUs. No university don't even have a couple hundred GPUs. So then what we're talking about? Everybody talk about AI. Then it just talks. Okay, we cannot do anything. That's the situation, right? So can we afford to lose this? Right now, at least this is for mainland China, right? This is the whole pipeline for construction. Almost every stage this can be improved with technology, right? And so this is some of the things that I think Zhexiang already started looking at. For some of you guys also mentioned, right, in the earlier talks, and from the measurement, from the digitalization, from the designing, structure designing, and so on. And also, right, this is a few startups, I think in Zhexiang and also from Hong Kong, they have started to almost every stage of the construction, right, from the measurement, the modeling, and the sensoring and the measurements. And those are the construction, right, even for moving the concrete, how to build the robots to move heavy objects and to do flooring, planning, and also to do all kinds of processing, right? Machines. Those are still at the startup stage, but already they targeting at different stages of the whole pipeline of constructions, right? And again, I think this actually intelligent construction brains can really help Hong Kong, place the Hong Kong or the Great Bay Area, right? Really leverage this kind of existing production pipeline, right? And to integrating the capability of productions, intelligent production, as well as even from all the level, from low level, from the chips to intelligent algorithms to the system design, right? To intelligent robots, right? So I'll just use a personal, very, very personal, what my take on this. See, human is the ultimate intelligent systems, right? We have the brain. The first part of my work really talk about AI is talk about building the brain, basically. The perception and the projection, right? Now, what's next on our body, which are equally important to our survival? Hands, right? Eye-hand coordination. Really, so that's why we can do things. It's our interface. Our eyes, brains are our interface, right? Hands are also the output, right? So we actually, construction worker, if you want to, we have to build something general purpose, right? Construction is very different from manufacturing. You can build a robot, just do one thing, very fast, very accurate, right? Construction is very diverse. Every society is different. We wanted to have some machine to do many different things. That's why construction workers still irreplaceable, because they don't just do hammer one thing. We don't even have machine can put on the light bulb, okay? Right? All the things, fixing things, right? And there has been some history, right? People try to build the robots hand, right? So maybe it's time to seriously revisit, right? This is a kind of robot, very valuable for construction type of applications, right? How do you play with balls? How do you use cubes? How do you operate them? This is some old history, right? So this is actually what OpenAI did. See, this is the mechanism, right? We all celebrate the success of OpenAI these days. We always look at the successful story. We never pay attention. In order to succeed in one thing, you probably have to fail in 10 things, okay? So this is a robotic project done by OpenAI. They cut it. Not because they're not successful. They have the robot hand. They actually can finish the Rubik's Cube, okay? But it's too expensive, the solution. They cut the team, okay? Consider as a failure. But you have to have an system to allow failure, to allow trying, to have truly breakthrough. Okay, if you don't have that, don't talk about, right, innovation. Right? So this is something really, really important. You look at even the success story. They take many, many iterations. Years of, even ChatGPT, right? GPT has 8 years of development. 1.0, 2.0, 3.0, 3.5, and so on and so forth. This is the same. So this is some work we did at Berkeley, right? We started also developing hands. So can we actually just be able to, first step, can we have the hands to just manipulate all types of objects? Not a manufacturing type, right? Because in construction, you really need the hand to be able to very dexterously manipulating all types of objects, twist them and manipulate them and so on and so forth, right? So the AI or some of the autonomous, as I said, right, this kind of give you a flavor, right? Precise the closed loop system design to get the system smarter and smarter, more and more autonomous, to be able to learn, adapt to different objects, right? So we will see more and more of this kind of technology, especially in construction. We really need to develop very dexterous and general purpose robots, not just to do good at one thing, but actually be able to really handle very, very diverse tasks, can reprogram, redesign, right? Redeploy to many different scenarios, projects, right? So anyway, this is just give a little bit, overview of the AI and also my personal sort of collection. What I believe are important. Some are still at the research stage, but this is the, I think it's the right goal, right objective for us to achieve, right, in the future. Thanks a lot.
Thank you, Professor Ma. Professor Ma, please kindly proceed.